here's what I want to do. So if you want to hang out and see a little bit about spanning tree, you can. So what I'm gonna do is put this diagram up. This, my friends, is the Cisco 3-tier hierarchy, and also a great complex network to demonstrate how spanning tree does what it does. Now, the reason I said this is going to take about 15 minutes is because it's not easy. I'm going to open a couple of my pen utilities. Hang on one second. I got to get these open just so I've got them. To do this, I literally use like 3 different pens so I can clear one and not have the other. So, by the way, this is my Epic Pen tool that pops in the middle of the screen. So let me move those aside. Okay, that way I can get some multiple colors going on. Okay, so first and foremost, if you're brand new to the world of spanning tree, let me give you the flyby. Spanning tree protocol has one function, and that is to stop loops, right? Because building redundancy into your network is a big deal. You want to have redundancy, and this is the ideal design for a redundant network. But without spanning tree, this network would crumble in a matter of seconds, because as soon as somebody would send a broadcast message, it would come into the switch, and switches send a broadcast everywhere. So it goes out both of those ports. These guys receive it, and they go, oh, okay, well, I'll send it out all the ports except it was received on. By the way, if you're studying for exam, all the ports except the one it was received on. So it goes everywhere. These guys get it. They send it everywhere. He gets it. He goes it. So within a matter of a second of sending a broadcast, you're getting, it's done. So what spanning tree does is it looks around the network and it says, I'm going to identify the redundant links, and it goes, redundancy right there. Now, I know some of you are like, well, that should be Ether channel. Well, we're not talking about Ether channel yet. So spanning tree will go, okay, I'm going to disable that link. Redundant. I'm going to disable that. So it picks links to disable, and it disables all of the redundancy to stop, famed geeks got it, a broadcast storm. So, HK John, if you enable spanning tree, the big thing is how does it do what it does? Well, the one thing, and the funny thing is, I for the new CCNA, I just finished probably an hour and a half of just straight lecture on how spanning tree does what it does. I'm not going to do that right now. I'm just going to cut to the chase and get to it. Hour and a half lecture, one command. That's literally all you have to do for spanning tree. One command, and the command lets you pick the root bridge. See, spanning tree does everything based around the switch that it calls the root bridge. And the root bridge, just in plain English, it should be the center of the network. But by default, spanning tree will choose the oldest switch in the network. And I'm not talking like the runtime. I'm talking manufacture date. And when I first learned spanning tree, I was like, that's dumb. Why does it pick the oldest switch in the network? Why it should pick the newest switch? Because if it picked the newest switch, then every time you brought in a new switch, if you didn't modify spanning tree, it would completely reconfigure the whole network. So that's why they did it that way. So the problem is, it's going to pick some, if you don't step in and configure it, it's going to pick some closet access switch as the root bridge. So, but I'll like, spoiler alert, here's the end of the story. Your job is to go in and just say, I want this switch. Let's just say, whichever switch you would consider the center of your network, I want that one to be the root bridge. And maybe if that one goes down, I want that one to be as backup. That is done using something called the spanning tree bridge ID. So there's your dictionary term. So every single switch will have a bridge ID. You can either configure it by setting the priority, or you can just let it be as default. So I'm just gonna, I'll just say these are all the bridge IDs. And by the way, the bridge ID is not a short little number like that. Like here, a default bridge ID might be something like 32,768 dot, 1111.2222.3333. The bridge ID is actually the priority, which we can change, plus the switch's MAC address, which we can't change. I know some people are like, well, you can spoof it. You can't. Not with spanning tree. That is static. You can't change that one. So here now here's where the confusion comes in. How does spanning tree do what it does? So first thing it does is pick the root bridge. And in our case, that's the easy part because we just said that one is the lowest bridge ID. That will be the root bridge. Okay. Now all of the switches, here's the magic of spanning tree. All the other switches are like, I must go to the center of the network. They're like little zombies. I must go. So they will find, I'll say step one is find their root port, which is the fastest way that they can reach that root bridge. Now, how does it find that root port? Well, it actually, and this, like I said, it's complex. Everything has a process. The first thing it's going to use is the paths with the lowest cost. And I'll explain this in just a second. If that's tied, it will go, okay, I'm going to use the lowest bridge ID. I know some of you are like, you lost me right here. Don't worry. Hang with me. I'm going to explain this. The third one that breaks the tie will be the lowest port number. Okay. So now let me explain. I just need to get that on the screen. So cost is based on a table. There's only two values that I would really recommend knowing if you're studying for the exam. 100 megabits per second is a cost of 19. Gigabit per second, I'll just put 1G, is a cost of 4. Just remember those two, and you'll be all set. So for the sake of this example, let's just say that all these links are gigabit per second. So 4, 4, 4, they're all a cost of 4, 4, 4, all the way down. So just imagine, 4s all over the place, right? So we've got 4s, 4 craziness, right? So let's just say I am this switch right here. He's going to say, okay, how do I find the best way to get to the root? What's the lowest cost to get there? It looks and goes, okay, I can go this way and it's a cost of 4. Or I could go this way and it's a cost of 4, and then I'd have to go that way. That's the cost of 4, plus 4. So, I could go that way, 4, 4, 4. So that would be a cost of 12, right? So it's going, no. I'm going to go this way. So hang on, let me change my pen colors here. You'll see why. It's a lot easier to understand. So that's going to be my root port, which is the one that I use to reach the root bridge. And freeze for a moment. There's a lot of stuff that I'm not telling you because I'm glancing at the chat and I'm like, BPDUs. BPDUs, Bridge Protocol Data Units, that's how they do this whole thing. That's like their sonar. Boom. It's like how they figure out the network, right? So I'm kind of letting that to the side because this piece is the most confusing piece for most people is how does it do it? Okay, so that guy's like, okay, that's my root port. This guy's like, okay, I could go this way and it's 4, or maybe this way and then I'm at 12. So it's going to say that's my root port. All these guys, that's nice and easy. Root port, root port, root port, root port, root port, root port. Step 1 of spanning tree. Oh, it's almost done. What about this guy? Forgot that guy. Well, okay, actually, that guy's a great discussion. Look at him. If he goes this way, he's got a cost of 4 plus 4. That's 8, right? Okay. He goes this way or that way or any of these other ways. Okay, that's also 4 plus 4. So that'd be a cost of 8. So this is where the lowest cost is a tie. Okay, so it's going to come down here and go, okay, my next one would be the lowest bridge ID. I'm going to take the path that has the lowest bridge ID. So it looks at this guy and goes, oh, your bridge ID is 10. Nah, nope, because I've got a friend right here. His name is 3. You're a friend, that's great, but 3 is lower, so that will be my root port, right? So you see how the second thing works, right? Oh, I cut off my T. So we've got our root ports elected. That's the first part of the process. Second part, and this is where most people get lost. Hang with me. The second port is it will light up. I'll just put turn on one designated port per segment. So let the questions flow. What is a designated port? Simple. It's a port that is forwarding. That's it. So a designated port equals a port that's active, a port that's alive, a port that's forwarding, right? So, okay, let me read it again. Each switch will turn on one designated port per segment. Oh, okay. Second question, what's a segment? Any one of these. This is a segment. This is a segment. A switch link is a segment. So let me just tell you, if you plug in a computer right here, spanning tree will run on this link and it will say, oh, this is a designated port because I've got one per segment. Okay, so let's do that. So let me use the color. Let's use green. Designated port. That's one per segment, right? Okay, designated port, one per segment. And by the way, I can tell you, the root bridge, that's its reward. It has all designated ports because if you look, every segment is going to have a root port connected to it, right? Because it's the root. So designated port. You could just go on that root bridge, DP, 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 right? So all of these are forwarding is essentially what it's saying. Now, hang on. I'm going to do the rest of the switches in just a second, but I want to make sure I say this. A lot of people look at that, they're like, why? Like, why is it doing that? Like, what's the point? Well, remember, you and I can look at this diagram and you can be like, oh, that's redundant. Let me block that. Ooh, that's redundant. Let me block that. Human beings can look at that. Computers are dumb. They don't know that. They're zeros and ones. So they need rules to make this happen. So somebody who's really smart said, if we follow 3 rules, and that's, by the way, where we're going, 3 rules, you've got 1, we've got 2, 3 rules, every single time we will end up with turning spaghetti into a perfect spanning tree network, right? So it's just the rules that they figured out, right? So we've got that root port. Oh, there's one designated port, right? 1 per segment. So pretty much anywhere I see a root port, I can go to the other side and put DP. Okay. Now, are we done? No. Because what about links like this? We need to light up a designated port right there. How do I know which side get it? Because only one side is allowed to get it. Remember, 1 designated port per segment. You can't have 2, otherwise you end up with loops. So it uses the same strategy to figure it out. It says, okay, I've got 3 and 4. We've got to light up 1 designated port on these interfaces. So first one, I'm going to say the switch with the lowest cost to the root bridge is going to be the winner, right? So you've got a cost of 4. You've got a cost of 4 too. So we're tied there. You both have a cost of 4. You both are really good switches. Okay, so the next one, it says, okay, the switch with the lowest bridge ID, you're going to be the one with the bridge with the designated port. So he's like, woohoo, I win. Designated port, right? And then these two are like, okay, competition's on. He's like, well, I got the lowest cost. He's like, oh man, I'm a loser. Designated port, right? Because he has a cost of 4. He has a cost of 8 to get to the root bridge. So the first one broke the tie there. He gets the designated port, right? What about this? So we've got this guy, cost of 8 to get there. And look at all these guys. Man, they're all these guys are direct to the root bridge. So they win. They got the better cost. So designated port. Now I know that may be like, oh, well, that's bad. That guy should have it. Well, honestly, it doesn't really matter because at the end of the day, we're going to fall down to rule number 3. Block anything that's left. These 3 rules will give you a perfect spanning tree network every single time. So it goes around and goes, oh, looks like right there, block. Looks like right there, block, 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 ah, block, 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 right? Block, block, bada bing. So let me do this. That, by the way, that is how you figure it out. And that is going to be on IC and D2. Wait, I can't say that. Hypothetically speaking, that might be on IC and D2. Not that diagram, but a spanning tree question like this where you got to figure out the topology, that's that. question from Network Negotiator. What about alternate ports? Same thing. Block. So when we were talking about that, hang on, let me hide my scratch for a second, because I think I got a switch. I use such good grammar. I got a switch right here. Check it out. I'm going to do show spanning tree on this guy. See this right here? Block is called alternate. It's just rapid spanning tree uses the name alternate, whereas the original spanning tree just said block, right? So, oh, hang on. You can see I was using my slide right from the series. So let me do this because this will. So thanks, Chris. She can join too, Chris. Come on. Let Chris finish. Join the spanning tree protocol. All right, so I'm going to scribble out. Look at this. This is what your final topology looks like. I'm going to scribble out all the links that are blocked. Chris, sorry if I got in trouble. That would totally get me in trouble. So scribble, 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 scribble. Right? Did we get them all? Oh, yeah, I think so. So then let me take I'm going green. Let's go green. Yeah. See? Network diagrams like painting. Right, like that. Get some happy little trees. There's the fire. Good. That is your spanning tree topology. That is the final topology that your switches will use, which, I mean, if I could remove all of those red links, half of your network would go down. And that's fine, because that's what spanning tree does, blocks the redundant links. Now, if let's just say this switch fails right here, it's going to just flip over and you're going to have all of the red links light up, right? So that's the beauty of what spanning tree can do for you. That's how you figure out the spanning tree topology. That's probably the part of spanning tree that people struggle with most. If you can remember, and I would encourage you, why don't I do this? I'm going to take this little how spanning tree works thing. I'll make it a separate YouTube thing, right? So you can rewatch it 1,000 times. If you remember these 3 rules, that's how a switch figures out the best way to get around the network. And these 3 rules, this is how the spanning tree process works. You've got spanning tree. You just have to practice it and do it again and again and again. Cool? Cool. Lots of questions. Let me glance at the questions real quick. That's going to be, by the way, that's just going to be what time we got? 3:42. I'm good. So I'm just going to take a few questions. Thank you guys, by the way. Someone earlier asked if I'm able to do CCNP route and switch material before February. Maybe. I'm not sure because ICND2, that's going to take a while to get through the practice exams and do stuff like this. Maybe. But I think right now I'm just doing CCNA till February because I'll tell you, my heart goes out to people that are like, I'm jumping into this game. CCNP is like, you're in the game, keep going. If you ever want to know why does Jeremy always run to talk about CCNA, it's because I connect with those people the most. There's just something that jives really well. So good. And I think that's it. Easily 3 port number. Like layer 1 or layer 4, what port number is the same? Oh, yeah. Actually, that's a great question. I got you easily. So here's what that means. So let me grab a different. I'll go black. So spanning tree protocol. Let me just draw this. So typical spanning tree topology. First thing is, let's just say this is the root bridge. The switches will try and find the lowest cost to the root bridge. So let's just say these are all 4. And so if these 2 are switches, they're going to go, okay, that's the best link. That's how they find it. But what if you've got a switch down here, right? That's where it's tied. You got 4. So it's like, so that's where it uses that bridge ID. So easily is saying, well, what does this mean? This topology, you won't actually get there. The bridge ID will always break the tie. You run into rule number 3 if you do this. Like that kind of thing would instigate rule number 3, where it's like, okay, same cost, same bridge ID. So port number 1, port number 2, port number 1 will be the preferred, port number 2 will end up getting blocked, right? So that's how that works. Hopefully I answered the right question with that. I was taking a stab at understanding it. Cool. So guys, I think that's probably the most valuable way I know how to help you with spanning tree in the least amount of time without just dumping a whole ton of stuff. So watch that again. I'll throw it up on YouTube. Watch that again. If you can do that, you've got spanning tree. That's the hardest part right there is figuring out how to do that. Cool. Well, guys, it's Friday. Happy Friday. Have a great weekend. Enjoy your studies. Be blessed. I'll see you next time.